Alright guys, so what we're going to be talking about this week is volume of pyramids. So the equation here is going to look similar to what we're going to do with cylinders next week. But for pyramids, what you're going to be looking at for volume is 1/3 base times height. Now this B is capitalized for a reason. And the reason that this B is capitalized is that capital B stands for area of the base. So area of that entire base. Same thing we did with prisms, so it's almost just the prisms formula where we're dividing it by 3. And the reason for that is any rectangular prism can be cut into 3 different identical volume, they may not look exactly alike, but identical volume pyramids. And then little h again is just height of the pyramid in the same way it was height of the prism when we were doing just normal rectangular prisms. So if we look at the first example, kind of in the bottom left corner there, you'll see a picture of it. We've got this pyramid who's got a height, you can see with the dotted line as it meets the base at a 90-degree angle, of 9, and then it's got 2 base measurements of 8 and 9.5. So we have height of the pyramid is 9 centimeters. We have height of the base is 8 centimeters, and we have, well, the base is 9.5 centimeters. So what we want to do with this information is first we need to find that capital B. So the capital B is going to deal with only base measurements. So we want to find the area of the base. In this case, the area of our base is somewhat rectangular. So our area of a rectangle is just going to be base times height. So in this case, we are just going to take our 8 times our 9.5. So that means our base is going to be 76 centimeters squared. All right, so now we have half the work done. So what we do with this number now is we're going to take it and plug it into our formula. So our 1/3 is a constant. It's always going to be there. It's not going away. Our base measurement is 76. And our height of our pyramid is 9. So when we take all those values, we calculate them together, do that multiplication, you should get 228 centimeters cubed. And by all means, guys, as I'm doing these, please kind of, if you want to pause the video and try them before I show you how to do them, things like that. Again, you can always take these numbers and go back and do them on your own without the video. Anything you want to do to help you better understand this stuff. All right, if you look at your second example, again, it's at the bottom left down here, your bottom left. We have another pyramid, but this time the base is a little bit different. This time our base is a triangle. So if you look at that triangular base, it looks like it's a right triangle. So what we have for just the triangle portion is we have height is 5 and our base is, it looks like 9 inches. And for now, this is the only info we need. So we need to find the area of this base. So if we remember the area of a triangle, that formula is 1/2 base times height. So we're going to take these values, plug it into that formula. So we have area is 1/2 of 9 times 5. So our area is half of 45. So that means it should be roughly 22.5 inches. And then again, this is area now. So we need to add that squared power. So these are square inches now. Now, if we want to find the volume of this pyramid, we use our formula again. So volume is 1/3 base capital B times height. So this is also our capital B. So now we just plug our components in. We have volume is 1/3. We have base is 22.5. And the height of our pyramid there is 10 inches. So when you run this through a calculator, you should get 75 inches cubed, or a lot of times you'll hear it heard cubic inches. All right, for this last problem here, if we look at it, the shape here has a pentagon base. So 5 sides, that's a pentagon. And what this means is this might give us a little extra work, but it's not going to be outside your realm of knowledge. So each of these pentagons, what we can do is a pentagon is comprised of 5 triangles. So if we draw those in here real quick. And I know this isn't the greatest drawing, but we have this pentagon, and it's comprised of 5 different triangles. Now, we know all these outer edges are the same, but for what we know right now, we don't necessarily know that these lines interior are the same as the outside lines. But what we do know is this is the center, so the center to any corner should be the same length. So we know at least this much. We know that these lengths are exactly the same from the center to corner, center to corner, center to corner. So if we use this knowledge to our advantage, and they give us a couple other pieces, they tell us that the length from the center to here meets at a 90-degree angle, and it's also 3 centimeters. So we know this is 3 centimeters. And they also tell us that each of these straight edges is 4.4 centimeters. And the way that they tell us each of those, if you remember, is these little congruency marks. So each of those has a single tick. So that means that each of those sides is congruent to each other. So the same length. So what we can do is we can leverage the information that they give us to get us to our final answer. So what we can do is we can find the area of one of these 5 triangles in here. And then all we have to do is multiply by 5 at the end, and that'll give us the area of this whole pentagon. So what we're going to do is, first, we're going to focus on just one of these triangles, and then from there, we just have to multiply to find them all. So if we look at just one triangle, we have this picture here. So what this picture tells us is that the height of that triangle is 3, and the base of that triangle is 4.4. So we know the area of a triangle is 1/2 base times height. So what we can do is we use this formula with our information. So area is 1/2 3 times 4.4. And what we'll get with that, when we multiply those all together, is we should get about 6.6 centimeters squared. So that's the area of just one triangle. Now we can see in this picture that inside that pentagon are 5 triangles. So if we take this 6.6 and we multiply it by 5, we should get that the area of our pentagon is right around 33 centimeters squared. So now we have the base covered. Now what we need to do is we need to use this base value in our volume formula. So if this is our capital B, our big B, our base value for area, we fill in our parts, so we have 1/3 times 33, And then the original height of that pyramid was 12. So we put the 12 in there. So now we have 1/3 times 33. This just boils down to 11. So we have 11 times 12. So when we multiply those together, we should get about 132. And again, that's centimeters cubed.